Okay, we're back. Okay, so in a whirlwind, in the first hour of class, we learned about the syllabus and saw all of that. And then we started looking at our code. So we created ourselves a GitHub repository that contains some scripts for creating the projects for this course. The first one we created was something called a student project. So let's take a look at the. Let's start looking at some code, and we'll figure out what the student is all about, and we'll start implementing it. So I use the recommended IDE, Integrated Development Environment, for this course is called IntelliJ. IntelliJ is very powerful, and in my opinion, the leading leading IDE for Java development, certainly, and also it's really good at Python, even C# and things like that. And while it's it's a professional version that many professionals use, there's also a community version, and I think there's also like a student license that you can get. And so I recommend that. You can use a different IDE. You can use Eclipse. You can use VI. You can use whatever you want. But I'm only going to answer questions about IntelliJ. I haven't used Eclipse in years, and there's a reason that I don't like it very much. Anyway, so open up IntelliJ, and you'll want to open up the project for, let's see here, in PSU, get Portland State, there you go, Java Winter 2020, and then open up the pom.xml. Now, pom.xml is the Maven project object model file that describes the project. You can watch the lecture to see more details. But open up that, and it'll say, hey, this, Clippy comes up and says, I've noticed you're trying to open up a project. You want to open it as a project? Yes, I do. So do that, and so it thinks about it. And now it creates an IntelliJ project with all that information. Oh, you know what? I opened up the wrong one, didn't I? Did I get it right, though? Looks like it did. Yay. Okay. I opened up the parent one, which is cool also. I meant to open up the child one, but this will actually work a little bit better. IntelliJ has these nice tips of the day, which actually, seriously, I recommend that you spend, you open it up and spend, 3 minutes every time that you open up to start going through these things to learn about the tool, the keyboard shortcuts, which, of course, are your friends. I have my IntelliJ configured with a special plugin that will pop up all of the keyboard shortcuts that I use. So I can say I can say open a file like student, and give you that bubble here. I'll make this bigger so we can see all of it. Over here on the left, there's a file browser. It's actually the project browser, but it's basically letting you look at all of the files that are available to the project. The parent project is called Portland State Java Winter 2020. There's a sub-project called Student. Inside the source directory is your source code. Target is all of the built and all of the compiled code. It's all in one place, so it's really easy to blow away. Like when you do a Maven clean, what it does is it blows away the it deletes all the contents of the target directory. We've got a class called Student, and I'll take a look at it in the project view. It's in a package. So a package in Java is a namespace for your classes. The package corresponds to, the name of the organization that creates it, edu pdx cs410j, and in this case the person, me. And in this class is a class called Student. Let's see here. Is that big enough that everybody can read it, especially in the back? No, I'm going to say no, that's fine. I'll try to make it a little bit bigger. And oops, sorry. I will try to make it a little bit bigger. This is where I always get confused. What is it? Shift Control Plus? Nope, that is something else. View. I don't want presentation mode. Oh wait, I remember. Is it scroll? Yeah, there you go. Okay, we'll go from here. See how that works. Okay. So our student extends human. Human is a class that is imported from my source code. It's pretty simple. A human has a name and it says something. Yeah.
Is human inside this directory?
Oh, that is not a stupid question. That is a great question, and I'm glad you asked. You might not be, but I'm glad you asked. The answer is no. So human, actually, when I hover over here, it might be a little hard to see, but IntelliJ tells you, hey, here's where this class came from. It's in a package called edu-pdx-cs410j lang, which is different in a different package. So I have to I import it right here. And it also says that it comes from a Maven artifact called edu-pdx-cs410j : examples, and the version of that is winter 2020. So the answer is no. The source code is not in this repository, but because Maven's awesome, I'm able to then tell IntelliJ, well, if you want to find the source code for it, Maven tells you where the source code lives. It goes and downloads the source code, and so now I've got the source code right here. And so then this is good because you'll be using my code in a number of places. We'll see what that's like when we look at the first project assignment. And then, that way you'll be able to easily navigate between the source code and your code. Sorry, my source code and your source code in IntelliJ. Yeah.
The pop-up when you're hovering over it, is that a plugin or is that?
Nope, that's standard.
Default?
Yep, should be there. Yeah, you have to hold down. Of course, you can't see my fingers. You need to hold down Command on Macs or Control on other platforms. Yep. Sorry about that. Yeah.
I'm not seeing the student. Did you say open up pom.xml?
Yes, pom.xml. Did you create the student project first? Yeah, interesting.
Maybe not correct.
I don't know. You did it. You worked. The first thing I always do is make sure it works on the command line, right? Fewest variables and stuff. If it's working for you on the command line, then are you seeing the same thing, that it's not opening it up for you?
No, different.
Okay, it worked for you. Okay. Poke at it a little bit more. If you're still having problems, raise your hand again, please. So, our student class is a human, extends a human, and students have some information about them. So here we have a constructor that creates the new student, and the student constructor takes the following arguments: the student's name, which is a string, the classes that the student is enrolled in, which is an array list of string, a double, a numeric, a decimal, numeric double, which is a GPA, the student's GPA, and also a string that describes the student's gender, which can be either male, female, or other, which is case insensitive. So here I have some documentation, and we'll see what Java docs are all about next time, next class, that describes all this information about the constructor. Now, the student class overrides the says method, and all students should say this class is too much work. Okay, right now it's not implemented that way, but our job is to implement this stuff. There's also a method called toString, which actually should override. I'm going to add an @overrides right there. That should print a description of the student, and we'll see in the assignment what that description is in a second. There's also a main class. Now, main is where the command line program begins, and it takes some command line arguments. And so what the main program does is it parses the command line, looks at the arguments come in. If everything's okay, it'll create a student based on that information and prints the description to standard out by invoking its toString method. So this is what the code is like. Let's look at the assignment to get a better idea of what this thing is all about. So there's all of the code. It's the same thing. And we've already done this stuff. That's one thing I didn't show you, is running the executable jar. So jar stands for a Java archive, and it contains basically all of the stuff you need for your application, all in one file. So your compiled bytecode, your class files, and if there's any text files that get read, there's any resource files that get read, or again icons, all that other good stuff, all gets bundled together in this jar file. And so then if you run the Java command with a jar option and then give it the jar file, which will be student winter2020.jar, it prints out missing command line arguments, because what it did was it ran the main method right here, which prints out missing command line arguments. So that's how you run the code from the command line. The goal of the project is to implement functionality such that when you run the command, when you run the program with arguments like Dave, male, 3.64, algorithms, operating systems, and Java, it prints out a statement like this. Dave has a GPA of 3.64, is taking 3 classes, algorithms, operating systems, and Java. He says this class is too much work. That's the end goal. Okay, so it takes some input, spits out some output. It does a bunch of Java along the way. As far as error handling is concerned, you'll see the same pattern throughout all of your projects. I want your programs to exit gracefully, have a nice error message. I don't want to see stack traces. I don't want to see null pointer exceptions, nothing like that. Because this is all part of the assignment, all part of writing good software, and all part of your grade. So it's important stuff to be able. Your program needs to do more than just the happy path. It's great that it works when it's supposed to work, but what does your program do when it's given bad information or when an unexpected situation occurs? That's really important too. There's another aspect of this project that is important, something I want to highlight. So I've used this project since the beginning of the course. And as many examples in software engineering do, they'll use something like gender as an example of here's how to use a Boolean. It has 2 values, true or false. And last year, one of my students, Trina, came up to me after the first class and said, I understand why you're doing that. There's some things about it that don't make sense. I'm not going to read this all to you because, and we engaged this really great conversation, and she said, this is what you and your students need to know about modeling gender or sexuality or race, that this isn't necessarily a checkbox thing, but this is an opportunity to, that you want your program and your software to represent all of its users and to be accessible by all its users. Because Trina made a really good point to me. They said, I can't test the software with myself. And I was sort of like, oh, right, it doesn't apply to you. And that's bad, right? When I write code, I want people to be able to use it. I want anybody to be able to use it, take advantage of what I'm providing them. I want them to find it to be useful. So if in a program that provides that only supports a binary choice for people that don't identify with that binary, it doesn't work. They can't use it themselves as a test case, and in a way it erases their identity and excludes them from using my software, what I want them to use. So when it comes to students, we won't model gender merely as a binary option, as a true or false. Instead, we'll use another Java programming language feature called an enum to say, hey, listen, there are multiple states of gender. This was an important lesson for me to learn as a software developer, as someone who is building software for people. And something that I wanted you to all be aware of as part of this project, part of the course. So this is the student class. This is what the student class should do. Now the end goal is to print out something like this. But to get there are lots of little steps along the way. And as I take each one of those small steps, I want to make sure that I'm doing the right thing. And as I take more steps, I haven't broken previous steps. So the way I'm going to approach this project, and the way that I encourage you to approach your projects also, is by using something called test-driven development. So the way of test-driven development, the idea behind test-driven development is that for every piece of functionality that you write a test. And as a matter of fact, okay, I've got a video to tell you all about it, which will require, which will require audio, though, and I didn't check the audio beforehand. So I'm going to crank up the volume. Maybe not that high. No, I'm hearing it come out someplace. I did not check to see if the audio even works here.
I think I heard a command on the speakers.
Okay, yeah, I guess it's loud now. We'll give it a try. Sorry, Uncle Bob. Okay, so this is a video by a guy called Uncle Bob Martin. He is a software luminary. I don't know what you want to call him. been around for a while and has over the years developed a lot of good ways of talking about object-oriented programming and programming in general. He's a leader in the software craftsmanship movement, which has helped bring the technical practices, help bring and reinforce technical practices in modern contemporary software development. So we're going to watch this little video here. This video comes from a series that he does called Clean Code. Their videos you have to pay for, but actually it's a pretty good use of money. And it's like, hey, your grandma wants to give you a unique Christmas present or whatever. This is a good thing for you to do. So let's see here.
Oh, it's time for the red.
He's kind of an acquired taste. It's effective. It's a little weird, too.
Green refactor cycle. And I am in the red phase. I must write a failing unit test. All right. What test must I write that will force me to write public class game?
Sorry, one more thing. I didn't tee this up very well. So what he's doing is he is writing a simple program that scores a game of bowling, right? So you're bowling and you get 10 frames and everything like that. And so he's starting from scratch, right? So he's got IntelliJ up here. He's got he's writing a unit test. This video is a little old. Some of the APIs are different now. But he's going to walk us through how he goes about approaching a problem from scratch. And that's what we all do, right? You got to start somewhere, and you start from the very beginning. And so where he starts is like, hey, what is the first test that I need to write? What is the first thing that I need what was the first thing that I need to be able to demonstrate with my program?
Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look. The test passes! It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Love.
Do you know what refactor means?
Take existing code and make it better.
Yes, take existing code and make it better. And what are some things that would make code better? I mean, it ran, right? So what are some things that would make it better?
You take redundant sections and make functions that encapsulate them.
Remove duplicate code, or if you've got copied code, put it in one place and just call it from one place. Yep, that's good. Yep.
Make it easier to read or more documented?
Make it easier to read, more documented. What are some things that make code easier to read? Sorry, what was that?
Comments.
Yep, comments. Yep. Doc things like that. Other things?
Good variable names.
Good variable names. Yep, always important. Yeah, class names. Yeah, naming important. Code formatting too, maybe, but your IDE should probably do that for you. Good. Yep, so that's refactoring. So he's got the silly hat on, but the whole idea is that in each iteration of test-driven development, you write a test that fails. You then write the code, the application code to make it pass, and then you look for opportunities to make the code better. And you do this in small steps, and at the end, you've got something that's the best it can be.
Lovely. Back to the red face. The next test, well, I know I want to write that roll method. All right, test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll, what should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that. Roll. And it should take a pins. This is lovely. And I believe that that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case.
Sorry, I want to point something out there. So you see what he did. He wrote the test case, got it passed, made some code changes, and then he reran his tests. Right, by rerunning your tests, well, I guess he refactored the test, but you make sure that what you did before still works. Again, working in small increments and getting feedback along the way by leveraging the tests that you wrote.
Back to red. Well, what can I make fail now? I got to write the score function. But I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0, I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Happy coding. Yeah. That's all right. So what did you see there? What are some of the things that Uncle Bob did, and what did you think about him?
You start with what you want your code to do, and you write failing tests that complain if that fails.
Yep.
And then you extend your actual code to satisfy those tests.
Right. When you write the test first, you write a usage of the code before the implementation of the code.
He also wrote, in order to make the test pass, he wrote the simplest possible implementation, which, I mean, I'm sure he would have gone on to fix it, but if this hard coding 0 isn't going to work as he extends tries to flush out the program. So, right.
Yes.
But you start with the simplest possible implementation so that you then move on to refactor it.
Start with the simplest thing that could possibly work. Why do it that way? I mean, come on, you know how to implement a game of bowling, don't you? maybe you don't. And for me, that's one of like the big lessons that I learned while doing test-driven development. And maybe it was kind of humbling in a way because I realized it's like, well, I thought I sort of knew all the ins and outs. I had this like, grand vision in my head, but then when I actually like was disciplined about developing it piece by piece by piece, I realized that it's like, oh wow, there are things I hadn't even thought of. Or it's like, you know what, I didn't even need all of that stuff that I thought I need. I could just do it more simply. And because I did a little bit along the way, I knew I wasn't breaking things as I add more things. What else do you observe? Where's the funny hat? Yeah, I know, right? Yeah. Well, cool. So, in our student code, there is a unit test called student test. And so then I have I wrote a test, and I'll make it a little bit bigger so we can see it, that when you create a student named Pat, that their name is indeed Pat. So you pass the student's name as Pat, empty classes, 0 GPA, and an unknown gender to the constructor, and then it creates an object called Pat. And then when you call getName on Pat, you assert that it equals to the name that you passed in. So sure enough, when you run this, that's to build all the stuff, and then it runs it, and it passes. Okay, good. So this much works. Now, looking at the assignment, what's the next test case that we should write? Where should we go next?
Maybe that the GPA is what you expect it to be.
Okay. So let's see here. So test, oops, public void GPA of, I can't have a decimal, can I? Of 3.05 is passed to student. No. Student has expected GPA. Okay, what do we need to do now?
We have a variable called GPA and set it to a value.
We need to create a new student. The name, cares, new array list, oops, GPA, and then, okay, assert that what? That our student dot get GPA equals the GPA we expected. Okay, I will create this method, and so I use option enter on the Mac to get a little help me pop up, and that's really small to read, but it says create GPA and student. I want to return a double, and then let's have it return 0. We'll go back to the student. We'll run it. Oops, we'll run it again, and it fails. Okay, so what do we need to do to fix this? What was that? The error message is that it expected 3.25 but was 0.0. It's failing right here.
So it's not actually setting the constructor. The constructor isn't actually setting. That's
Yep.
the problem.
Let's move that up a little closer. Okay, cool. So now what do we want to do? We want to put the GPA parameter into a field.
Do we have a private variable?
We do now. And then we want to use that GPA down here. And now we'll run our tests again. Yay, it passes. Nice. What else? What's next?
Would you do it for have a test individually for each of the fields in the class?
We really wanted to, but I'm thinking that the big functionality of this is to parse the string of Dave, male, 3.64. Actually, that's a list of strings in Java.
It's the arguments that are passed to the main method. Yeah, all this right here. Yep.
We need a function that's going to do that, and we need a test to make sure that it's parsed correctly.
Yeah, right. And that's, it's perfectly all right to sort of start with the end in mind and sort of say that's where we need to get to. Actually, let's cheat a little bit and do that, right? So let's see here. If we so let's see here. Public void. This is example student from assignment. And let's see here. So this is Dave, and that's a new student named. I'll just copy this whole thing here. Into a comment. So let's see here. Dave, and then what's the next parameter? Classes. So that's new create local variable, array string equals new array lists, and then we'll add takes algorithms, copy and paste because I can't spell. Algorithms. Operating systems classes.add Java, that I can spell. Let's see here. It needs a GPA of 3.64, and the gender is male. Okay. Okay, great. So we've created Dave. Now, what do we need to assert about that?
We're just going to assert all of the various fields that are in Dave are equal to those specific things.
Well, but that's not really what the assignment's, right? I mean, ultimately, we want to spit out this big old string here, right? And this is what the toString actually. So Dave dot toString equal to this big mess right here. And let's see here. There is not a new line there. Operating systems in Java. He says this class is too much work. And you know what? There should be 2 spaces after that period, damn it. Okay. Well, let's see here. If we run this test, where are we at? Not implemented yet. No kidding, because I haven't implemented toString. Okay. Cool. So this is where we want to get to eventually. Where do we go next? What's the next thing to implement here?
Test the classes.
Sorry?
Test the classes.
Right. And so, like, what functionality do we want to go? What we want to implement first? How about we just start implementing the toString method? Go from there. So let's see here. Okay, here. But you know what? Before I want to do this, I want to ignore this test because it's not passing yet. That's perfectly fine. And then I want to go and like run all my tests. Good, they all pass. So what I'm going to do is from IntelliJ, I'm going to commit these changes back to GitHub. So I'm trying to make this. Can I make this any bigger down here? I cannot. And I do that. Sorry, I went to the version control view in IntelliJ. If I then right-click and I say commit, This will commit the changes to the local repository. So added a unit test for GPA and the ultimate test for the assignment. And I can say either commit or I can say commit and push. I'll just commit. No, I'll commit and push. Oh, it's telling me that there were some warnings with that class. That's fine. I don't want to review them. I'll just commit and push them. I'll push it up to GitHub. And now if I go back to my GitHub repository and I reload, oh good. There's the unit test for GPA and that. So it's pushed up there. The nice thing, IntelliJ has good integration with Git, and so it's really easy to just push your changes up. And maybe I push my changes too often, but I like to sort of get a test passing and commit, because that way I know I always have a known good point in Git to go back to if something breaks. Okay. So now, let's say this toString contains student name. And so now what I'm going to do is I'm going to turn all of this into a method which is getDaveStudent. Let's say getDave. Okay. And now I'm going to use that here. I'm going to say student Dave equals getDave. Actually, I don't even need to say that. All I need to say is that assert. Yeah. Assert that Dave getDave dot toString contains string nope. Contains. Just contains. Shoot. So this is where Dave forgets the API. There is an API called Hamcrest, which is an anagram for matches. Hamcrest. Oh yeah, there it is. That has all of this awesome stuff. So let's see, here's a base matcher. Contains. Come on, string contains. But contains string. Yeah. Contains string Dave. Oh, here we go. Import static method. Yes, from there. Great. Oops, and this is at test. So now I run this guy. Okay, it says not implemented yet. Okay. Well, so then what can we do to get this test passing? Looks like the toString method contains Dave, so gotta do something to the toString method, right? Okay, what do we need to do to the toString method? Okay, I could do that.
Or the actual name.
Well, what should we do? What would Uncle Bob do?
Minimal.
Man, maybe don't answer that. But
Minimal.
minimal, right? And this is sort of like where it's like, well, come on, we could do this, get it passing, and maybe that's the right thing to do, because then we can write another test, another unit test for a student with a different name, and then, well, no, right? This is the conversation that you need to have in terms of like, where does it make sense to do that? Yeah, let's just say, let's not. Let's say get name. Now, should I do anything else? The answer is no. Don't implement anything more in toString, even though you know it'll have to contain other things later. Wait for another test. Again, you add just enough code to get the test to pass, so that you're writing minimal code. It's really easy, and I've done it, a bunch of times in my career. Well, hundreds of times in my career, where I've written more code than was necessary, and that just adds complexity. It adds more stuff to read, more stuff for things to fail. Just do the bare minimum to get things working. And at the end, your tests will tell you when you're done. Cool. Okay. So that student name contains that. I'll move this up here. Okay, let's do GPA next. Contains GPA. So it should contain, has a string, has a GPA of 3.64. Says, nope, that failed. It expected to have a string containing, has a GPA of 3.64, but all it was Dave. Okay, so let's go back and add that now. Oops. Has a big caps GPA of this dot GPA. We'll get GPA. Why not? Run it. Oh, it failed. What didn't it like? Oh, haha. You click here to see the difference. IntelliJ is smart enough to tell you, oh, look, there is a space here on the end of what was expected. There's no space there. Wah, so let's add a space. Cool. Okay, let's commit our work. Added unit tests for toString, well, for name and GPA with in toString. Oops. Quick push. Push. Actually, what is it complaining about? Because I don't like those wordings. They're bothersome. Saying, can be package protected. That's true. This does not need to be public, so we can get rid of the public. And then what else doesn't it like? Oh, it doesn't like the fact that class isn't used yet. Same thing with gender. We'll get to that in a moment. Okay. What's next? Do we need to test with different values of the GPA? Yes? What value should we test with?
2.5.
Okay.
I was going to say an impossible GPA,
Oh,
so like 25.9.
okay.
And there should be a check in there that prevents the GPA from being that high. And obviously the tests will fail because we don't have the check in.
What should happen when a GPA is 25.5?
I would throw an exception to this.
Okay. What kind of exception is thrown? In a legal argument, exception is thrown.
I don't know if Python.
Do you have a question back there, or are you just flexing? Okay. Yeah. Keep it
I
up.
was gesturing.
Okay. No, there's a dude behind you. It's cool. Okay. So this is name. No classes right now. Whatever. GPA. We decided this is going to be a GPA of 2.5, and gender is other. Oops. How did that get messed up? Oh, let's delete this. Okay. And then here with this student, we want to assert that student.toString contains string has a GPA of 2.5 space. So now we'll run this one. And it passes on the first try. Oh, I don't get to like change my hat or anything. So, is it valuable? I don't know. Gives me a little bit of confidence. And I suppose if I then, yeah, if I had been like, done the naive implementation has always had it return 3.64, the string 3.64 instead of doing GPA. Yep, that would have been a good test. So yeah, let's leave it in there. It doesn't really hurt anything. Like Uncle Bob says, it's cheap. That was 37 seconds of my life I'll never get back. But yeah, cool. This other test. So when you mentioned the invalid or the super high GPA, I captured it here. One of the things that I like to do is have the names of my methods. I mean, it's super long, right? I mean, it's hard to read, but it tells you what it does. And for me, it's like a way of taking notes of like, oh yeah, hey, there's a situation. And so I use this format that's used a lot in testing called given, when, then. So given some set of conditions. So like I have a student, with this name. When I do something, so in this case, like when a GPA is 25.5, then I expect something to happen. I expect an illegal argument exception to be thrown. So the way you write this is that you say student equals, okay, so new student name. You know what? Well, here's what I'm going to do. I'm going to do some refactoring here in order to make this next method easier to write. What I want to do is I want to create a method which is like, hey, create me a student with a given GPA. So I'm going to take the GPA up here, and I'm going to refactor, and I'm going to say extract variable. So now create a local variable, and it tells me, hey, how about call it GPA? Great idea. Okay. And then what I'm going to do is I'm going to take this code right here, and I'm going to say refactor extract method. It says, hey, I'm going to call it get student with GPA. Yeah. And it's saying, hey, listen, I found another example of that. No, I'm going to keep the original signature. Thanks, IntelliJ, but I'm going to say skip that one too. See, it's trying to be helpful. It's like, hey, I noticed your creating method looks like this. Here's some other places that you could use that method. Very often, yes, I want to do that. This is not one of those times, though. Oh wait, or maybe did I just do? Maybe I just did the wrong thing. Maybe that was the one I was supposed to replace. No, wait. Yeah, that does look a lot like that. So let's just try it. Get student with GPA. Maybe that was a good idea. And I can tell it's a good idea if I run the test and it passes. Yep, yep, 6 passed. Actually, I'm going to show the passing ones here so we can just all see it. Yep, all of those tests pass. Now I can write a new one. So let's see here. When I do get student with GPA, actually I want to call it create student with GPA. I don't like get. Create student with GPA. Oh, sorry. I'll show you that one too. There's a refactor rename. And then that lets me say create student with GPA. And the GPA is 25.5. I expect a legal argument exception to be thrown. And the way I say that is I say here I say expected and then legal argument exception dot class. So that says, hey, listen, I expect that this method will throw an illegal argument exception. And if it doesn't throw an illegal argument exception, it should fail. That's what it's supposed to do. Now if I go and I run this test, it fails. It's saying, oh, I expected that there be an illegal argument exception. And now what do I do? What do I do to get it passed? Yeah.
Put the check into the constructor of the student.
Okay.
And throw in a legal argument exception.
Okay. So let's see here. What is the check? So if GPA
Should be less than 0 or greater than 4.0.
what are we testing here?
Oh, in this case, it's just greater than 4.0.
Right. Well, I agree that that a -1, but do we have a test for it? No. Don't write code before you have the test. This is all part of test-driven development. This is all part of the mentality, the mindset of saying I'm going to write the minimal amount of code. Or it's like I'm not going to allow myself. It's like some sort of anyway. I'm not going to allow myself to write code until it's absolutely necessary, until I have a test that is valid that demonstrates that I must write that code. Okay. Throw new illegal argument exception. GPA is too big. Nice, that passes. I think we just came up with another one. So when GPA is less than less than 0. Your intersection was thrown. So minus 25.5. Run this one. It fails. Make it pass. Else if GPA is less than 0, throw new illegal argument exception. GPA is too small. Nice. This is good. So again, we're working incrementally. We're sort of exploring the problems, exploring the, okay, now we're looking at, we started out with printing GPA. It's like, oh, well, what else do we need to know about the GPA? Oh, its size. That's important too. So now we're validating all of that. Since we're talking about GPA, is there anything else that we need to do with it? Any other test cases related to GPA that you can think of?
Make sure it's double.
Is what?
It's a double.
Okay, so like, what would the test be to make sure that it's a double? So when GPA is, what would is there like a value that you're looking for? Is there a
any string?
Okay. Now that's a good point. I mean, like on the command line, it's just sent as a string, right? Now, interestingly enough, in the sorry, where am I looking for here? In the student constructor, it's typed as a double. So if we're just using the constructor, we're prevented from sending a string there, right? It wouldn't compile in the first place. But that's a very valid test case. Maybe not for the logic of the student class, but maybe for the logic someplace else when we deal with the command line. Let's hold off on that. So probably the rate we're going, it'll be next week. We're going to look at how to test things on the command line, and that's where that logic's really going to come into play. So make a mental note. But that's definitely a valid test case, not for the class, but for the command line program. So, anything else related to GPA? I can't think of anything else. So, oops, what doesn't it like here? Oh yeah, I saw this. Okay, so now let's go back. Sorry, I want to say one more thing about this. This is another thing about test-driven development, where it's like, aha, I know eventually I'm going to need that, but today is not that day, right? We don't need it right now, and so then filing that away for the future is also an important part of having the discipline to just really focus on one unit, getting that working, and then knowing that you're just not done once you have this class working. You just have like this logic working here. So let's see here. Validate that the GPA is between 0 and 4.0. Okay. Yeah.
Why don't we write down all the test case first, then come up with a more general idea of the solution, right? Is that easier?
Well, that's a good question. I mean, should you write all of your test cases first? There have been times where I found it to be very effective to like brainstorm all the test cases. As a matter of fact, when you approach your code katas in the pair programming, the mob programming, I recommend that you do that. Understand the problem by putting up test cases, by that given when then. It's like, okay, hey, when I have this scenario, when I do this, I expect this output. And as a matter of fact, maybe next time when we talk about the command test in the command line, we should do that because we'll be familiar enough with the class, and so with like the domain object, and so really testing that main method, it might make sense to sort of brainstorm all of the things, figure out what things are already covered by the unit test, which things are necessary to validate against the command line. So yes, I think it's a good way to start and a good way to understand the problem. But there's also a lot to be said by sort of feeling your way around and by saying, okay, well, what's the next test case that I need to write? And then when those ideas pop into your mind, where it's like, oh, I'm not ready for that. Yep, write down on a piece of paper. Maybe write a test for later on that you can go back and implement. So I guess what I'm saying is that there's not like a right or wrong here. It's what's fit to purpose, and the purpose is to have working software with enough code coverage that you can feel confident modifying that software quickly, modifying that software and having that safety net provided by the unit test so you can go fast. Nice. Okay, well, we did GPA. Let's go back to our big solution. What's next? Oh, let's tackle the classes. So here's the class. Let's do classes and see how that goes. Public void, Dave. Actually, what was that called? ToString contains your GPA. Yeah, okay. Dave's ToString contains his classes. So this would be assert that Dave. Oops. Get Dave.ToString contains string. This big thing doesn't need. Oh, that's cute of IntelliJ. Sorry. Ugh, I can't read that. I'm going to put this into a variable so I can read it better. Just too wide. Classes. Okay. So now when we run it, yep. Okay, so it doesn't contain that at all. Where do we go from here? I think this is a lot to bite off all in one fell swoop. I want a simpler test that we can make work. What would be a simpler test that we could drive to green before we tackle the whole big thing? You answer a lot of questions. I want to give someone else a chance.
Start with just one class.
Yep, one class. That'd be a simpler test case. I was thinking about something else specifically, though. What was your idea?
The size of the collection of classes, that should be tested separately.
Okay. That's what I was thinking, actually. Is that, okay, hey, I just want to look at, like, maybe, does it have the number 3? So, public void Dave's ToString contains 3 classes. Okay, that's a little easier. I'm going to ignore this other one so it doesn't trip me up. Okay, phew. This seems like a little easier to deal with. So ToString. So, oops, there was some boilerplate there, and is taking 3 classes. ToString. Okay, it's not taking 3 classes. It's taking, hey, if I do a variable here, can that work? Number of classes. Oh, look at that. That's so neat. Okay. Okay, now this should actually make it pass, but this is lame. Let's just make sure. So let's let me know that I got the strings format correctly. Great. Now we don't want this to be a string. We want it to be an int, and we don't want it to be 3. We want it to be something else. What do we want it to be?
Size of the array.
Yeah, that array list that we pass in. Okay. So we'll just store that off in a field. And then down here, we'll just say this dot classes dot size. See if that works. Hey, it worked. Pretty awesome. With regard, okay, so this one's working. Any other tests that we should do for the number of classes? What about the test case that he mentioned? What happens?
The string is going to change on. You have one class that should be pluralized,
Yeah.
and also the distinction of commas and the and there.
Good point. Right. Yeah. And so we got to think ahead to that. Yeah.
Cases.
The word class is singular. Singular. What's so funny? No, seriously. If there's this is a good this might be a good observation, or is it's not okay. Yeah, okay. Okay. So here we want is taking one class, right? Oh, he's taking 3 classes. Oh, right. Yeah, that's not Dave. Sorry. Okay. So then this will be student. And then this will be new student. And then it's name. Collections dot singleton of one class isolate list.
That won't return an array list, it'll return to your.
Oh, you are correct. Nice going. Yeah, you're correct. Oh, sorry. Okay. I'm going to refactor and inline that, which basically takes that string and replaces all. It takes the variable and replaces the variable with the value of the variable. So it just does that. And now I can have another variable called classes, which is really what I want. And that will be an array list. Equals new array list. And then find classes dot add one class. GPA 1.23, gender other. Okay, now let's run it. It should work, right? Oh, it runs. Well, wait, is that what we wanted? Did we expect it to pass? Why did it pass?
Oh, because class is in classes.
Yeah. Okay. So we got to be a little more specific about what we expect there. Oops. Let's see here. It should be taking one class, maybe colon. Taking one class colon. Ah. Okay. Good. Now it is. Now it's failing. So let's see here. Now we say, let's see here, if num classes not equal 0, then append es, otherwise append nothing. Is that going to work? Oops, did I get it wrong? Oh, 1, not 0. It's a little thing. This is what, okay, I'm not a very good coder, but because I work in small increments, I find this stuff out immediately as opposed to like 3 days later, I'm like, why isn't my program working? So, right, I mean, this is secrets of software engineering revealed here. Hey, I don't usually write code at 7:50 at night. I'm kind of tired and I'm an old man, so luckily I've got tests to make up for that fact. Oh, still doesn't like it. I don't have the semicolon. I never did add the semicolon. There we go. That's working. Now, the moment of truth, did I break anything? So I'm going to run all of my classes, now all my tests, to see if anything broke. Nope, it did not. Yay. Okay. Nice. Any other test cases related to the number of classes?
I don't know if it's relevant, but I mean, like illegal values, like negative numbers. I don't know if that's relevant here.
How did you? Let's write the test. How would you write the test?
Test avoid when classes is less than number of classes is less than when student takes less than one.
Well, no, you're working through something important here, right? It's like, oh, right, this is a number. It should blow up when it's negative. Oh, how do I do that? I don't think you can, right? You can't have an array list with like with less than 0 elements. So now there's nothing wrong with like thinking that way. Remember, it's really good to think that way. Look for the weird edge cases and stuff. This is the time to validate it. But I'm not sure you can do that. That's okay. Not a bad thing.
What about duplicate class? Like you're taking the same class twice?
Oh, yeah, okay. Well, what should happen in that case?
Duplicate class exception?
Okay. You guys are laughing at my log?
It's descriptive.
Exactly. You know exactly what it tests, right? Well. Nice. Okay, let's do that then. So, and then takes the same class again. Sure, let's be cheeky here. And this should throw, let's throw expected, a duplicate class exception. Okay. This exception doesn't exist. That's okay. You can create your own exception. So let's do that. And you're smiling. It's like, what? I've never done this before. No, this is the kind of stuff that you do, right? You're writing your code. So you want to create the class. Now be sure to create it in the right place. You want it to be in the source main. So I'll put it over here. I don't want to extend throwable. I want it to be a runtime exception. Oops, runtime exception. I probably don't. It doesn't need to be public yet. Okay, let's run this one. Expected exception, duplicate class exception, and it wasn't thrown. Cool. So here in the, I'm sorry, I was assuming that you want it should be thrown in the constructor. Does that seem like a reasonable place as opposed to waiting until the toString, right? Guys, you look at data validation. You don't have a valid student if they're taking the same class twice, so therefore you shouldn't be able to create a student with the multiple classes. Okay, nice. Throw duplicate class exception if contains duplicates. Oops. How do we implement this? Hash set. Tell me more.
So you can start with a hash set of 0 elements, and as you traverse through the array list, you can add the elements to the hash set. If you add one that already exists, it should throw the exception.
Cool. We'll learn about hash sets and things like that, but what is a hash set? What is a set?
I don't know how it's internally implemented.
Right. Who cares how it's internally implemented? Like, how do you use it? We're more about using things than understanding how it's used here. Container, it has a specific property that I'm trying to get at. I love it when we all speak at once. Yeah.
It contains no duplicates.
Contains no duplicates, right? Every element in a set is unique. A hash set is an implementation of set. That's backed by a red black tree, blah, 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 blah. Learn all about it in the week 2 lecture on Java collections. Cool. So yes. So we will say this is we'll have a set of a set. We'll call it a set equals new hash set, and you can give it something. You can give it a collect. You can give it classes, and then what doesn't it like? Oh, hash set of. No. It's a hash set of. Sorry. I want a set of strings. Hash set of string. There you go. And then if set.size doesn't equal classes.size, then throw new duplicate class exception. Yeah, I see what I don't know. Maybe I'm being too tricky there. I don't know if that makes sense or not. But it passes, so it must do the right thing. Is that code hard to read?
I just didn't know that you could pass a collection to a hash.
Yeah, I don't know if that's really a good thing or not.
You just use a set instead.
To do what?
Just instead of an array list.
Oh, well, how can I use an array list?
Because a set's abstract, right?
Well, set is an interface that's implemented by hash set. Yeah, you could. And that would, yeah. And so that way you wouldn't need to check it anymore. Not, at least not here. You probably need to check it like when you're adding it to the first place.
You still shouldn't be able to provide duplicate sets. You should
Yeah, and so it sort of is a question of where do you want to validate the logic. So yeah, it's probably better to implement it as a set. Yeah, let's do that instead. And so we really can't. Then this actually. Okay, sorry. Let me get this working, and then we're going to do some refactoring to make that possible and see what it's like. Oh, look at that! It's even telling me. You probably can't see it. It says, "Hey, instead of calling add all, you can replace it with a parameterized constructor," which is nice, but I think it's a little harder to read. I think this makes a little bit more sense. So let's try this. Okay. Cool. Now, I'm about to do a big refactoring, so I want to commit all my code because we might want to like throw all this stuff out, or I might completely mess things up. So throw a duplicate class exception when a student is enrolled in the same class multiple times. What time is this? 8 o'clock. Okay. Okay. Yeah. Let's change this to a set. That is going to be a pretty big refactoring, and that's okay. Let's be bold. So if we change this to a set, got to change a bunch of stuff to a set. We got to change this to a set. Actually, we don't even need this anymore. Oh, well, yeah, no. Let's see here. Now, all of those array lists need to be sets. So I will use string replace. I will say array list with sorted set. Oh, sorry, that's impossible to read. Replace all. Nope, not sorted set. I wanted hash set. Okay, the code is. Oh, look at that! It's even. IntelliJ is saying, hey, you're doing something fishy here. You're adding the same string twice to a set. Nice. Well, let's just see what happens. Okay, so now I'm going to run all my tests again. Oh, haha. Oh, this is going to be a good one. Oops. Come on. We're on the test. I'm hitting the wrong keys here. There we go. Okay, everything passes. Except that expected a duplicate class exception, which doesn't throw anymore. So I think this... Is there a way to test this? I mean, like, what? How would we test it now?
Yeah, you can test really.
Hey, there you go. I like that. Right? This test now becomes not useful. Okay. Nice. Okay. Oh, okay, so I take that out, and I run all my tests again. Yeah. Awesome. So, see what we just did there? We made a fundamental change to the class. We took something that was an array list and now made it a completely different type. And yep, we had to change a bunch of code, but we had tests. And I could run all the tests, and yep, the one that we kind of expected to fail, failed. Everything else passed. Great. I haven't broken anything. This is the power of test-driven development. It gives you the confidence to make big changes, take big risks, because it'll tell you whether or not it broke something, and because we're using GitHub, if something like had gone terribly wrong, we could have just reverted it to the previous known good version and started over again. So, nice. That was a good example. Thanks for suggesting that. Okay. Model the classes that a student takes as a set. Nice. Push. Okay. 8 o'clock and it's like 80 degrees in here. Let's take a break. Okay. So another 10 minutes. Stretch your legs. I'm going to get some more water. I need to bring like a drink or something maybe next time. And we will start back up again at about 8:15.